today we're combining some of the stuff we learned on day 2, which for us was this past Tuesday, and a little bit of new stuff. So if you happened to not have day 3 done yet, this isn't going to completely be impossible. We've got the third root of 27 z to the 9th. We're going to split this into the third root of 27 and the third root of z to the 9th. Using our handy-dandy perfects chart, what is the third root of 27? 3. The third root of z to the 9th. I'm going to take z to the 9th and split it. So I've got the third root of z to the third, the third root of z to the third, and the third root of z to the third. Z to the 9th means that there's 9 factors of z underneath the radical. There are still 9 factors of z under the radical. There's 3 of them right here. 3 more makes 6. 3 more makes 9. But by splitting them up this way, when your index and your exponent are the same, the third root of z to the third, the radical and the exponent cancel each other out, and this becomes simply z. The third root of z to the third is z. The third root of z to the third is z. So what do we have here? We have 3, and we have z to the third. Now, if I asked you to write it out like that every single time, that's tedious. That's a lot of work. So is there a way to go from the third root of z to the 9th to z cubed faster? Basically 9 divided by 3. How many groups of 3 are there in 9? There are 3 full groups of 3, so we have z to the third that comes out of the radical. Basically, we're going to be looking at like division with remainders. So like how many groups of 3 are there in 10? There'd be 3 full groups with 1 left over. And if you are not very good with short-term memory, like me, I'll show you a trick to help you with this. Okay, number 2. We have the third root of 8, the third root of r to the third, the third root of s to the 5th, and the third root of t to the 10th. When it's all smashed together, this looks confusing, but if you split it up and do one little piece of this at a time, it's not too bad. So first, perfects chart. What is the third root of 8? 2. Next, the r's. What is the third root of r to the third? That is simply a plain r. For the third root of s to the 5th, how many groups of 3 are there in 5? There's 1 full group. After we take that 1 full group of 3 out, how many are left over? 2. So there is a third root of s squared that's still left over, stuck under the radical. Now, my short-term memory issues, I think, okay, there's 1 group of 3 and 5. Well, shoot, now how many is that? How many do I have left over? I can't keep track of it. So instead of writing out third root of s to the third root of s squared, I use dots. It's kind of like, remember when you had like counters on your desk in elementary school and you had 5 things, split this into groups of 3, and you had 1 full group and then 2 left over. So I make dots. 1, 2, 3, 4, 5. Here's my full group of 3. That becomes the plain s. Here's my 2 that are left over that are still under the radical. So if you are more of a visual person, you can use dots to help you split this up. Especially helpful when you get to larger numbers like the third root of t to the 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 3 full groups of 3, so that's t to the third. And then this one little guy is still left inside a third root. Now, what do we do with all of these pieces? How do we put these pieces together into an answer? you have to put the pieces that are not under a radical together, numbers, then letters in alphabetical order, then a third root symbol, and then anything left under the radical, numbers, then letters in alphabetical order. The nice thing is we started in alphabetical order, so all we're going to do is look left to right, first at things that are not under the radical. So I have 2r s t to the third. Then I'm going to make a third root symbol and go through and find everything left to right that's still stuck under a radical. S squared t. Now to you, this doesn't look simpler than what we started with, but mathematically this is simpler because there are no perfect thirds left under the radical. To simplify a radical, you need to take all of the perfect whatevers out, and so we did that. Okay, turn the page. We have one more of these, number 3, to try. For starters, we'll split this up into the 4th root of 12, the 4th root of d to the 4th, the 4th root of e to the 9th, and the 4th root of f to the 14th. Now work on each piece, trying to break it up, split it up. Anyone having trouble with 4th root of 12? In the 4ths column, the only thing smaller than 12 is 1, which doesn't help us. So that stays 4th root of 12. It is possible that it might just stay and you can't simplify it. Now see if you can work on the D's, the E's, and the F's. If you're watching the video, pause the video. 4th root of d to the 4th is simply d. 4th root of e to the 9th. Because the index is 4, we're now looking for groups of 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 2 full groups of 4, so that's e squared. 2 full groups, e squared. And 1 left over, so 1 is still stuck under the radical. F to the 14th. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have 3 full groups, so f cubed. And 2 still left over under the radical. Getting all of these pieces is your first challenge. Your next challenge is putting these pieces into a cohesive answer. Go through from left to right and look at stuff that's not under a radical. We've got d, e squared, f to the 3rd. That's the first part of our answer. Then I do a 4th root. This is why it's important to tuck that index into the checkmarky part. You really want this to obviously be f to the 3rd times the 4th root of something and not f to the 34th. The 4th root of 12e f squared. Using what we know about the properties, we can split this into the 5th root of g squared over the 5th root of h to the 7th. And now let's simplify what we've got. How many groups of 5 are there in g squared? Are there any full groups of 5? No. So we're going to keep this 5th root of g squared. Sometimes you can't simplify it, and that's totally fine. On the bottom, how many groups of 5 are in h to the 7th? 1 full group with 2 left over. So 1, 2, 3, 4, 5, 6, 7. 1 full group of 5, 2 left over. There's a problem. This can't be our answer. We can't have a radical on the bottom. I know. So this is a problem. This needs to be the 5th root of h to the 5th. Because if it was the 5th root of h to the 5th, what would that actually be? That would clear it and make it just a plain h. It's currently the 5th root of h squared. How many more do we need to get to a full group of 5? 3 more. So I'm going to multiply by the 5th root of h to the 3rd on the bottom and on the top. Whatever you do to the bottom, you're going to have to do to the top. I actually like this better than rationalizing with numbers because it doesn't involve the perfects chart. It's just we need a group of 5. We currently have 2. We need 3 more. Now what happens when we do this? On the top, we have the 5th root of g squared h to the 3rd. That's fine. On the bottom, we have the original h that we simplified in our first steps. And now we have this full group of 5, which is going to become its own h. So we have the original h and the new h, so we have h squared on the bottom. A lot of people forget about the original h that we simplified originally. Give this one a try on your own. Remember, we start by splitting up the top and the bottom. See if you can simplify the bottom and then see what else you need to complete a group of 4. On the top, we can't simplify anything. On the bottom, we're looking at how many groups of 4 are in 6. There's one group of 4, so we've got a plain y, and then we've got 2 that are still stuck under the radical. This is bad. We can't have the 4th root of anything on the bottom. So we want to turn this into the 4th root of y to the 4th because then it would be just a plain y. So we currently have 2. We need 2 more on the bottom and the top. On the top, we've got the 4th root of x squared y squared. On the bottom, I'm going to write out a few more steps here. Really, we have y times the 4th root of y to the 4th. These two things become the 4th root of y to the 4th. The 4th root of y to the 4th is simply plain y. So on the bottom, we have y and y, which would be y squared. And on the top, the 4th root of x squared, y squared.